good today. Right. Um, it's a good start, isn't it? Mm. Right. What the fuck? That's like two. Okay. Yesterday, I figured out a bunch of ways to not make audio work. I realized something after. One of the things that got me confused was the syntax, because this is like the syntax for declaring a slice. I swear, my mic sounds like totally weird. Mic check. This is better. Oh, not really. It's okay. Maybe it's just me. Who knows? Who knows? Right. I almost trying to hold in the right. Bit distracted. I think it's the lack of sleep. 2 nights in a row. But whatever. Doesn't make that much of a difference if I don't let it. I am rambling. So I forgot what I was doing yesterday. I know, yeah, fuck. Yeah, this won't work because obviously this is fucking comp time unknown. And it's an array, which makes sense. I gotta declare something. Once frames are available, you can begin. Yeah, before we can actually write a frame. So this is our buffer? No. Shouldn't this be the size of the buffers we need? How did I do it for the window? Whoa, this is so wrong. Oh, okay, no, it's not. No, it's fine. Okay, so let's do it step by step. So no, where's my audio? Yep. So it's areas. It's not the buffer. Let's just point it to areas in the audio. Something buffer. I don't know. Where with these offsets, these many frames, and these are the pointers to those areas. So we don't know how many there are. What is channel area type? Okay, it's a struct. I don't think this is the same thing. Available frames. On visual, yeah. This time. Yeah, there's no point building. I need to. Yep. Available frames 4800. Offset looks wrong. Frames look wrong. Areas look wrong as well. This is just some like overflowed number. Just trying out. At some point I did get... No, still wrong. Let me go read again. This function will return the number of frames available to be written to the output buffers. It's worth highlighting that this function returns a signed value. Once frames are available, you'll need to call mmap begin. Well, one of the problems I can think of is... No. Does it not return an error code as well? Okay. Maybe that error means something. It is a negative error. Map. Okay. Do I call that? Yeah, I do. Yeah. Function can return wrong count available frames. I did see this example. Generate sine wave. Start start the transfer when the buffer is almost full. Then PCM SW param set start threshold. What is the buffer size? Buffer size equals size. Extract buffer size from a configuration space. No idea. So cold. Okay, anywho. Start the transfer when the buffer is almost full. Buffer size divided by available min. Okay, it takes 2 more arguments. No, that's a different method. What are these patterns anyways? Thought we said it already. Okay, these are HW params. Whatever that means. Okay. I think I have no understanding of the API. I want to ask some questions. In the Alsa API for Alsa lib for sound, can you achieve the following? Set params for audio, get areas in the buffer that I can write to. And then play. Don't want any code, just want to understand some basic concepts. And also, I have no clue what I'm doing. Setting. Okay, so that's what HW means. Hardware parameters. Okay, now we're getting somewhere. To configure your audio stream, think of telling Alsa exactly what kind of audio data you'll be sending it. Sample rate, we know that. Sample format. Yep. It's like 16-bit LE for Little Endian. Number of channels, buffer size. How much audio data? Yep, for about 2 seconds of buffer size. Period size. How often Alsa will interrupt you asking for more data? Interesting. This one I'm not sure what it means. Don't think I need this. Excuse me. Doesn't look very active. Yeah, I'm not sure what that is. It's quite the challenge to find docs for Alsa. I think it was just here. Tutorials and present. I think I checked this already. Don't know what's happening to my words. Feel like I'm slurring. Oh fuck, it's an expired link. Well, that's been a common problem. Come across that a few times. I think I've been here before. Actually, what I should ask is... Okay, let me just read through this. Pretty good so far. Let me make some notes here. Move this to init. Excuse me. So buffer size is amount of audio. No. It's like, let's say you want 2 seconds of audio, always there. Would it be amount of memory you'd need for your audio from the hardware ring buffer? Yeah, sounds good. And then period size. Period size. I don't know what this is. How often Alsa will interrupt you asking for more data? Interrupt frequency. for more data. Yeah, not sure what that is. Okay. Alsa uses a circular ring buffer to manage audio data flow between your application and the sound card. The key concept here is areas. I've seen areas a few times now. Within the ring buffer where you can write your audio samples. Write audio samples. When you ask Alsa for writable areas, it gives you pointers to memory locations where you can write audio data. Okay. Yep, I sort of got that. Information about how much space is available, details about the memory layout. Okay. And then details about memory layout. Available space. The ring aspect means that once the buffer fills up, new data wraps around the beginning. Yep. Open an audio device like default. Configure your parameters. Yep. Prepare the stream for playback. Enter a loop where you repeatedly ask Alsa for available. Okay, so this one's got to happen every time you want to write audio. Write audio samples to those areas. So I'm guessing it's possible that sometimes there's no frames available to write. Tell Alsa you've written data, commit the areas. And where can I find documentation on the above? Is this the same one? Yeah, I do remember this guy. This is what I used initially. Okay, I think that's everything I need. So I used the minimal playback program. But this one is for single channel. Oh no, it's not single channel. It's two. Oh, capture program minimal. So I would assume this is what I need. No, this is not what we need. Maybe let's look at this one. It also uses right eye. It doesn't commit anything to the areas. No, interesting. Guess that's why in here it says write to the buffer when it's almost full. Why did I say that? Maybe it was here. Yeah, it was here. Yeah, start transfer when the buffer is almost full. Okay. Maybe let's start here. By this point, there's also already a handle. Let's be main. Yeah. What's the device? Okay, it's a parameter. Is that a default? Stream playback. Okay, most of it seems right. So I guess let's set the hardware params. I did use this is the simple one. You can check if it covers all the variables. Hardware params. Set rate resample. Why do we get buffer size from get buffer size? Does that mean extract buffer size from a configuration space? I don't get it. Yeah. Set params. Really? I don't even remember where I found it. To the same place. It's like such a pain in the way. Pain in the ass way. to set params. Like, no, I've seen this many times now. Hang on. Data access and layout. This controls the way the program will deliver / receive data from the interface. There are 2 parameters controlled by 4 possible settings. One parameter is whether or not a read-write model will be used, in which explicit function calls are used to transfer data. The other option is to use mmap mode, which is in which data is transferred by copying between areas of memory. API calls are only necessary to note when it started and finish. Data access and layout. Jeez, these guys are like relentless. Why can't you just like fucking stop? Okay, so I haven't set a map mode anywhere. Let me check the hardware parameters again. Read write interleaved. Set format channels. Okay, I didn't see these at all. It's probably why don't know what's the difference between in the Alsa API. What's the difference between these? Note. I only want to write. You get direct access to Alsa's ring buffer. Yep, that's what we need. Actually, this one is much simpler. But to stay consistent with Handmade Hero, I want to try this. We want the mmap modes. Multi-channel data is interleaved in a single buffer. Okay. Right. Okay, so that's the one we need. Interleaved. Mmap. Okay. What I'd like to know then in that case is will I now get the areas? Okay. Something went wrong. Signal is not mapped to object. Access type not available for playback. Invalid arguments. Okay. I don't know what that means. Hang on. Why non-interleaved? Each channel has its own separate buffer. No, I just want this one. It's much easier. Samples are not interleaved, i.e. there are two buffers where 8 samples will be written to. Access type. Excuse me. Access type not available for playback. And something went. I mean, that's the only difference. Okay. Oh, it was worth a try. Right, time to ask Cloud. How do I get this error when I set patterns to don't support a map mode at the hardware level. Interesting. Hmm. Try opening hardware device directly. Okay. Guess you want to use the first one. Is that it? Hardware. Let's see. Oops. Yeah, good question. List of devices. So it comes from the mapping of your hardware. X is the card number, Y is the device number. Okay, they both seem 0. It's optional. What if I don't specify anything? Unknown PCM. That doesn't work either. Can I print the errors? Okay, that is printing the error. Okay, device or resource busy. Alsa, device or resource busy. What does it mean? No. This is more like, ooh, maybe this one? Damn, this is wild. It's not the easiest thing to do. I might have to submit. Okay, let me ask Cloud, see if it's get device. What do I get? Oh, resource busy. I'm trying to connect to I mean, that is possible. Because I never clean up the connection. Yeah, should do that. Net. Okay. Gonna switch it back to default. And I guess gonna have to change this to read write interleaved. That means don't need this. Don't need any of this. Don't need any of this. So if I write the sine wave to the sound buffer, I should be able to. Yeah, okay. At least that was working. I'm gonna see if it builds. Shouldn't play any audio. Okay. Okay, so I need to fix this. Okay, now I need a sine wave. How the fuck do I get a sine wave? Or make a sine wave? Actually, can I just write? Don't even need the for loop then. Okay. Let me see if I can generate a sine wave. Should I go back?
So what we want to do is we want to go and every sample, depending on which sample we are at, we basically want to go ahead and make a square wave. So we want to be able to basically just do, if our sample index happens to be, the first n samples, it's going to be high positive. It's the first, if it comes after that, the next n samples are going to be low and high and low and high and low. So we're going to use the mod operator for that probably. So basically what we're going to do here is we are going to actually, well, we don't even really need to use the mod operator. We could be a little more janky than that. So basically what we're going to do is going to find a variable that's going to tell us where we are in our sawtooth pattern. We are basically going to call that, I'm sorry, not our sawtooth, our square wave pattern. We're going to call that our square wave counter. And basically all that's going to do is if the square wave counter happens to be 0, so we're done, it's basically we've finished one part of our square wave. If the square wave counter happens to be 0, we are going to set excuse me. Man, I wish I could get healthy again. I can't tell you how frustrating it is to be trying to talk to you and have this stupid cold in my way. It is really annoying. All right. Anyway, this square wave counter is going to basically go up to the number of samples that we want our square wave to have high before it goes low, and vice versa. So basically what we're going to do is we're going to say, well, if our square wave counter, I don't know, I'm going to pick a random value here and then we're going to tune it later, square wave period or something like this. We're going to reset it each time. Again, this is kind of ugly the way I'm doing this, probably not the best way to do it, but it's the first thing I thought of. So we're going to make it do that way. And then what we're going to do is we're going to say our sample value is just going to be whether or not the square wave counter happened to be above half the square wave period. Basically, that's about it. That's all we're doing. If it happens to be above that, then it will output the highest possible value that it can. Well, maybe not the highest possible value. Let's just say 16,000. Yeah, I don't know how loud we want this thing to be. Basically, this is a 16-bit value, so 32,000 is the maximum it could be. 32, whatever it is, 65536 divided by 2. And if the square wave period, if it's not that, if it's in the other half of the square wave period, it'll output the negative. That's basically all I actually want to do here. And these are basically the exact same loop. So we'll probably compress these in a second down to one loop. But that's basically it. That is all we wanted to do. So all we really need to do now is make sure that we actually fill out all these values somewhat reasonably. I believe that's correct. Okay. Someone on the stream said, let's code a mini Moog synthesizer and emulator instead of a game. You know what? That is Sean Barrett's turf, ladies and gentlemen. I am not the person to do that for you, but I bet if you asked Nothings at Twitter to do a stream where he codes a Moog synthesizer for you, I bet he would do that. That is exactly the kind of thing that he would do, and he is exactly the kind of person who would know how to do that a lot better than I would. I would just end up writing a lot of crappy code like this that I just wrote for you because honestly, I never synthesize sound really. I always play from some kind of sample materials that get mixed together. So this is way out of my area of expertise to say the least, but it's definitely the easiest thing for us to write to just get things going. Okay. So we need some stuff here we have not finished because we have to define some things. Obviously we have a square wave period, and that square wave period is going to have to be something reasonable. We also have to make sure that we actually decrement our square wave counter every time we output a sample, right? Something like this, just so that it starts to count down to 0 as it should, and so it will repeat. Now the square wave period, I don't really know what the average square wave period should be for a sound that you can hear. Let's say middle C. What is the frequency of middle C? Okay, so middle C is in hertz. Basically what hertz is, if you don't know what hertz is, it's cycles per second. Basically what that means, if I go back over here to our amazing diagram, basically what you can imagine is we had that square wave, right? It's going like this. And similarly, you might have a sound wave, that goes like this. And basically, I believe the way they typically measure it is a cycle is how long it takes to go back to where you were. So from like one peak to the next peak, right, like this, or from here to here, basically, for one complete copy of the pattern of the wave. That is basically called a cycle. That is what we're considering a cycle. And so hertz is just cycles per second. That's all. So basically, if we are going to play a sound for 1 second or fill a buffer that's 1 second long, then you can imagine it should have 261 copies of that pattern for middle C. Basically, that is what that means. So if we try to back this out here, if we're trying to figure out what our square wave period should be, basically what the value is, maybe I'll go here and say what the hertz is. So we'll try to get a hertz, something like that. So I don't know, let's just say 256 should be close enough. I want a power of 2 just because I'm a programmer like that. That'll be somewhere close to middle C in theory, I believe. Should be fine. So if we're wanting to actually do 256 cycles per second, right? Then the question is, how many samples do we need to fill? Because again, this is going to be in samples here. How many samples do we need to fill before we actually have that many? How many samples for a full, for one of our loops? So basically what we want to do is we want to say, well, hertz is samples per second, right? So all we have to really do is say that whatever our sample rate is, and we know what it is right here, we set it, so I could even say this is our samples per second, right? That we actually asked the sound buffer for. Oops. That we actually asked the sound buffer for. There it is. Samples per second. If that is our samples per second, then we basically know that if we want to have 256 of our thing, then each one of them should occupy basically the number of samples we're actually going to do in 1 second divided by the number of the things we want in 1 second, right? Because that's how many chunks there would be. That's how many samples would be per chunk if we chunked up our full second into 256 slices. So I'm going to say that's roughly our square wave period. We're not trying to be precise here. So I'm basically going to say that that is what we will actually fill out. So now this should work, I think. We can go down. Let's see, we're writing that many samples. Yes, we are. So what we have to do here now is we have to actually turn our region sizes into counts, right? Because these are sizes, these are byte sizes that are coming back, and we actually need sample sizes. So like I said, we got to assert that they're valid, and then I jumped into an explanation and forgot to finish what I was trying to do here. We need region 1 sample count, right? Because this is how many bytes, but we know that our samples are actually 32, so that's 4 bytes per 32-bit sample, because we have two 16-bit samples, a left and a right. So basically what we have to do is we have to divide this here by our bytes per sample, right? So by our bytes per sample.
Okay, I think I don't really need to do that, so I could just build a buffer here. Samples per second. I guess. Does that make sense? It's like 256. I am quite bad at fucking sound. Samples per second, so that's this is more. So during one cycle for a square wave should go from plus max all the way to negative. And then back. And then repeat. So when it reaches the maximum, it should go back to it should start going back down. And this should happen every, I don't know, every something. Whatever that means. This is about 2 seconds. Alright, let's give it a go. Let's try something. Hmm. I'm like stumped. I have no idea. Oh, actually, no, it's a lot simpler. At the halfway point, we need to just switch the thing. What? I'll bring this down. Sample rate divided by hertz. So what am I doing here? And play time. Then put current frequency. Yeah, whatever. Equals 8,000. Mm, 32. Then current playtime. want that. And then now sound buffer of I is equal to current frequency. Does that make sense? Actually, this can be negative. Yeah, how do we flip? U16 is... Okay, this can be an int. Maybe I should take my headphones off. Do I actually run it? No, I do, right? Okay. Just gonna put it far away. Just brace yourself. Okay, didn't play. That scared the shit out of me. Current playtime. Guess this can be I32 as well. Maybe I should put the volume down. I don't know if that'll make a difference. Fuck. Okay, nothing happened. Ooh, that was scary. Segmentation fault. Where could I have gone wrong? I swear that's the same sound it played last time. Oh, it did play it last time because the volume was too low. Is that the same sound that he plays?
Do we hear it? Wow.
It is.
Well,
okay. Or at least it's a weird way to test. Why is there a segmentation fault? Hang on, let me check the sound again. Yeah, it is the same sound. Nice. Can't believe I got that sine wave. Jeez, my ears. think I don't. Yeah, I'll leave that on. This. Okay, the window doesn't open. Oh, why does my jaw hurt from that sound? I guess I could just allocate this buffer. Sound buffer size equals undefined. Where's my allocator? I think I need to allocate the handle too. Just hold on to your ears. It's gonna be a bit loud. Just wanna see what the error is. Segmentation fault at address stats. Mem copy fast. it in 32 or 16? In 16. And then some buffer size. And then how do I allocate seed stuff? Can I even? That looks quite wrong. You mean it's never mutated? I don't think that's gonna work. Allocator. No size available for that. Yeah, that's what I thought. Do I even need to? We'll see it again. Cast discards cons qualifier. Oh, so this is quite janky. Yeah. I don't think it's gonna work. I'm trying to be. Oh, hang on. Oh no, sorry. How can I allocate a seed type music? Do remember seeing something here. Jeez, they never come twice at the same day. Yeah, for interrupt with C libraries. If I'm not wrong, I did see some allocate. PCM scope malloc. Where's the documentation gone? Here. Quite ugly. Oh, hang on. What am I doing? So, then don't need the sound buffer here. C pointer. Expected type. Blah 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 blah. not it, is it? 35. Talk about being a pain in the ass. Okay, think I know what to do. And here, get rid of that. Pick types. Oh yeah, of course. Yeah, because I need the handle outside. Small problem of allocating C pointers in Zig. I'm so close. Where's memory? Well, that can be optional. I'm sure that would have worked. I do have to assign a value. Mm-hmm. And if I do that, I need to know the value. No. Pain in the ass, this shit. Can't be a const either, because I need to be able to modify it. Will that work? Oh fuck, what am I doing? Could have done this whole... Okay. Just get rid of this shit. Yeah, and then just... put it here. Return. Is not available. Trace. Okay, so it's got to do something with lip sound. Get the shit out of me. I was not expecting that to work. Can I see which? Where is the caller? Okay, here. Ah, yeah, of course. Sound buffer. Hang on. Yep. Jeez. Oh. I'm sorry if you're on headphones. Play audio. Yeah, and this. I think it's already a pointer, no? Yeah. Okay. At least the audio works. The window doesn't work anymore. Stop. And then let me. I should probably reduce the volume. Okay. Valid. Valid permission for mapped. So maybe I shouldn't map it. What if I turned it into some buffer and then add a sound buffer? Hang on. It just. Alright. Motherfucker. Still fails. Is it the same error now? How do I write a window? It's also a back buffer. Index. Pointer cast buffer dot memory. Yep, pretty much the same. An optional cons pointer, any opaque. I mean, the audio does work. It's what happens after. No. Fuck. How do I go? Yep. Alright, I think I'll leave for tomorrow. Memory. I lost the error. It's alright. Error here. Yeah, I have no idea. Never seen the error before. Okay, but at least the audio works. I'm guessing. Yeah, I think tomorrow I'll sort it out. What's after? Variable pitch sine wave output. Yeah, okay. Once the audio works. Yeah, okay, whatever. We'll figure it out tomorrow. At least I don't need. Ooh, maybe I can check. I did check. How do they? Handle pointer, C pointer. Signed short. Okay, not complicated at all. Alright, never mind. I'll take it tomorrow. It's a problem for tomorrow. I'm gonna call it. Actually, is there something I wanted to figure out? Do how do you raid someone else? Stream manager, maybe. Never mind. It's a problem for another day. Alright, thank you for hanging out. I'll see you tomorrow. And yeah, have a good day. Kind of. Well, we made progress, so I think that's the most important part. The audio works, and it sounds exactly what he played. And sounds like it, and anyway. Just gotta fix that memory thing, which I don't know what it is yet. It's gonna bother me. I'll figure it out tomorrow. Alright. Have a good day. And as always,